The Arctic is not stable. It only looks that way. Sea ice disappears in summer. The system adjusts. Shipping lanes shift. Wildlife shifts. Weather shifts. Food trade moves. Insurance models move. Coastlines move. Not over centuries, but within decades. Not slowly, but within a lifetime. The first changes are subtle. The middle ones are persistent. The later ones are systemic. And by the end, the world still functions, just differently. We are now facing the near certainty of a summer where the Arctic Ocean is almost entirely free of sea ice. This is not distant. Scientists can see it approaching with alarming speed. An ocean of dark water where brilliant white ice stood will not be an isolated event. It will trigger a cascade of changes felt across the planet. The weather we experience. The food we eat. The fundamental change is simple. White sea ice acts like a giant mirror. It reflects a large share of the sun's energy back into space, keeping the planet cool. Dark, open ocean does the opposite. Like a dark shirt, on a sunny day, it absorbs heat. When the ice is gone, the ocean absorbs more energy. The Arctic warms even faster. That heat moves into the atmosphere and along ocean currents. It does not stay at the pole. Imagine a July shoreline in northern Greenland. Open sea to the horizon, damp air, waves where there was ice. An ice-free summer Arctic is a tipping point, changing wildlife, communities, and the systems we rely on. To grasp the scale, consider the Arctic today and how fast it is departing its historical state. The Arctic is warming more than twice as fast as the global average. Arctic amplification. Each year, less sea ice survives the summer melt. The remaining ice is younger and thinner. Old, thick, multi-year ice is now rare. First-year ice dominates and melts easily. Since the late 1970s, summer sea ice loss is roughly the size of India. Imagine that area simply gone. The decline is not smooth. Record low years push the system toward an ice-free state. Ecosystems evolved with reliable summer ice. Now, change is compressed into a single generation. Many species cannot keep pace. Infrastructure, economies, and agriculture were designed for a climate that is disappearing. This is not passive warming. Arctic ice is part of Earth's regulatory machinery. The steady beat of seasons and stable coastlines are tied to polar health. As the Arctic transforms rapidly, consequences follow quickly. Open water, damp air, and surf become the new summer sensory baseline. Wildlife and people alike now operate on thinner margins. The fate of Arctic ice is linked to the stability of systems across the planet. The most immediate consequences of a summer without sea ice fall on wildlife woven to the ice. Polar bears rely on ice as a hunting platform for seals. With ice gone for months, bears retreat to land or swim exhausting distances. On land, they hunt less effectively and face more conflict with people. Longer ice-free seasons extend fasting, lowering body weight and reproductive success. Seals birth and protect pups in snow layers atop sea ice. Without stable ice, pups are exposed. As the ice edge retreats from shallow feeding grounds, walruses haul out on land in dense gatherings. Crowding increases the risk of deadly stampedes for young animals. Under ice algae feed tiny crustaceans, copepods, and krill. They, in turn, feed Arctic cod, seals, narwhals, and belugas. Remove ice, and the base erodes. New warmer water species may move north, but they cannot replace intricate cold-adapted webs. Without an ice buffer, storms directly erode thawing permafrost shores. Villages built on frozen ground face rapid erosion and costly, painful relocation. This is not only ecological. It threatens homes, cultures, and livelihoods. A sensory shift marks a new Arctic summer. Arctic changes ripple south, reshaping weather for billions. The jet stream, driven by the temperature gap between poles and tropics, weakens as the Arctic warms. A slower, wavier jet lets weather systems stall. Storms linger longer, increasing flood risk. Heat waves become more entrenched, stressing power and health systems. Cold snaps can dive farther south and last longer. Evidence links persistent European heat, catastrophic Pakistan floods, and severe Texas freezes to jet stream shifts. Loss of summer sea ice is a key driver, injecting extra heat into the Arctic atmosphere. The warming Arctic can influence ocean circulation like the Atlantic meridional overturning circulation. Warmer, fresher meltwater can slow overturning, altering rainfall patterns and regional sea levels. Changes can touch systems from Asian monsoons to the U.S. East Coast. Arctic signals export volatility across the network. Simple chain. Ice loss adds heat. Heat shifts winds. Winds lock patterns. Feedback loops amplify change. One push triggers the next. White ice reflects sunlight. Dark water absorbs it. Less ice means more absorbed heat and a warmer ocean. A warmer ocean melts more ice, reinforcing the loop. Permafrost spans nearly a quarter of Northern Hemisphere land, locking ancient organic material. Warming thaws ground. Microbes decompose, releasing CO2 and methane. Methane traps far more heat than CO2 over short periods, accelerating warming. Added heat drives more thaw, a self-reinforcing cycle often called a carbon bomb. Arctic warming accelerates the Greenland ice sheet melt. Warmer seas erode glacier fronts, speeding ice flow to the ocean. This adds to global sea level rise, linking Arctic melt to distant coasts. As bright surfaces shrink, darker areas absorb more sunlight, accelerating melt. One cross-section, sea ice loss warms oceans, thaws permafrost, releases gases, and feeds back on ice. An ice-free summer opens shorter Arctic routes between Europe and Asia, saving fuel, time, and money. Shipping firms and nations invest in ice-class fleets in northern ports. But the environment remains harsh. Icebergs, sudden storms, fog, and limited rescue capacity. Accidents are difficult to manage. Cleanup is slow and costly. Undiscovered oil, gas, and minerals attract exploration, raising sovereignty and legal questions and indigenous rights concerns. Short-term profits contend with long-term systemic costs from extreme weather. Droughts, floods, and storms disrupt harvests and damage roads, bridges, and grids. Insurance markets strain. Public budgets absorb disaster relief and recovery. 4 million people live in the Arctic. Indigenous communities face travel risks, shifting hunts, and rising costs. Thaw heaves ground, cracking buildings and buckling roads. Some villages must relocate. Adaptation is necessary. Resilient housing, protected shorelines, and reliable food systems. But the rate and severity ahead still depend on how fast emissions fall. Slower warming can mean rare ice-free summers instead of a permanent annual feature. One system, many links. Remove the northern mirror and the network rebalances around new risks. The choices we make now will decide how quickly this future arrives and how deep it runs. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.